Hi everyone, my name is Juliana Noronha, and today I'm presenting my final project for Data 690, which is the AI Wardrobe Stylist. This is a personal outfit recommendation system that takes a natural language prompt describing your mood or occasion, checks the live weather for your location, and returns a complete outfit drawn exclusively from your own wardrobe. Here's the roadmap for today. If you remember my last presentation, some of these slides will look familiar. Last time I covered specifics about the models I used and how cosine similarity works. I will not be covering that during this presentation to provide more time for the scenario walkthroughs and the failure analysis, which is where the most interesting findings live. So the problem I'm solving is one most people experience but don't really think about. Research shows that the average person leaves about 82% of their wardrobe unworn in any given year, and the average adult owns 118 clothing items, with a quarter of those untouched for over a year. I believe the root cause isn't a lack of options, it's that mentally searching your full wardrobe, filtering for weather, occasion, and mood, and assembling a coherent outfit is demanding enough that most people just default to the same small rotation of clothes and outfits, while the rest of the wardrobe just sits there. As I covered previously, I had many more ideas for this project than are feasible in an 8-week span with no budget. So my scope is a single user personal tool built around my own wardrobe, which is 105 clothing items. It will accept a natural language prompt. It will real-time query the weather via the OpenMeteo API, and everything is running on Google Colab's free T4 GPU. The right column shows some of the other ideas I had for this project, but did not implement during this 8-week time period. This includes multi-user support, mobile upload, calendar integration, and so on. So in plain terms, here's what the system does from a user's perspective. You type something like, "I have brunch with friends today, something relaxed." And the system automatically fetches the weather for your location. It searches your wardrobe photos semantically, so that's not by keywords, it's by the actual meaning of the image. And it returns actual photos of specific items from your closet with an explanation of why they work together and work for the occasion. So that's 2 inputs, a prompt and a location, and 2 outputs, a real outfit from your real clothes and an explanation. So here's the full pipeline. The top half shows what happens once up front. You photograph all of your clothes. Blip2 generates a plain language text description of each item, and Fashion Clip generates a 512-dimensional vector embedding of each image. Both of these get stored in a database alongside the image path and the category. The bottom half shows what happens on every request. So you would enter a prompt and your location, and the system would call the weather API for the weather at your location. And then this is an architectural change I made during the project. The raw weather data gets converted into a short descriptive natural language string before, and it is also passed into Fashion Clip along with the outfit prompt, so that during the candidate item stage, the weather can be used as a factor. So that looks like 58.9 degrees F, rain, wind speed, and precipitation chance, which are all very technical weather descriptions. That becomes cold, rainy day, just through fixed Python logic. There's no LLM involved in that. And that gets appended to the outfit prompt and passed into Fashion Clip to convert that combined string into a 512-dimensional vector in the same embedding space as all of the clothing images. And then we can find the 3 most similar items per category in the database using cosine similarity. Those candidates, along with their descriptions and the weather context, get passed into the LLM. In this case, we're using Llama from Meta, which selects a coherent outfit and explains its choices. The system then fetches the image files for the selected items and displays them in the Colab notebook. I will cover this architecture change in more detail when we get to the scenario results. So we have two user supplied inputs, which are the prompt and the location. But additionally, the system also takes in the weather data, which is fetched from the OpenMateo API, and the pre-built wardrobe index in ChromaDB. So the other user prompt there is the actual clothing photos, but like I said, that only happens once. On the parameter side, we have top K, which is the number of candidates items retrieved per category. We also have the actual models chosen for this project, which were Blip2, Fashion Clip, and Llama 38B. These could be swapped out with other models, and I'm sure that would have a really big impact on the resulting output. Model parameters, which are things like temperature and num beams, were tuned through grid search and manual evaluation of the outputs. We also have the system prompts for both Blip2 and Llama, which have a significant impact on the output quality, which I'll come back to in lessons learned. The outputs are outfit photos and a plain language explanation from Llama with the choices driving each step. Before I jump into the scenarios, a quick note on how I evaluated the results. I defined 3 KPIs at the start of this project. KPI 1 is simply whether the pipeline runs end-to-end for all 3 scenarios. KPI 2 is a measure of retrieval quality, so did Fashion Clip surface relevant candidates, and did Llama select relevant outfit items. I set a target of 80% relevance across the 15 items retrieved per scenario. KPI 3 is to measure the final output quality, and that one's very simple. Would I actually wear this outfit under those circumstances set by the user prompt and the weather? The target here was passing in at least 2 out of 3 scenarios. Since this is a personal recommendation system, I believe I am the most meaningful evaluator, and there's no external benchmark that captures whether an outfit is right for my taste and my wardrobe. So I ran 6 total different scenarios. So that's 3 occasions, each tested under 2 different weather conditions. Rather than hard coding the weather artificially, I used 2 real-world locations to meaningfully represent different climates. So I chose Bergen in Norway to get cold and wet weather, and Marrakesh in Morocco to get hot and dry weather. For the 3 occasions I tested, I wanted to get a casual outfit, a professional outfit, and like a more formal romantic outfit. So these 3 occasions multiplied by the 2 weather conditions give me 6 scenarios tested, but I'm just going to walk through the best and worst performing run. The best performing run was the professional meeting scenario in Bergen. The prompt I entered was, I just got called into an unexpected client presentation. I need to look polished and professional, but still be comfortable enough to sit in it all day. The code cell on the right shows how I entered those into the system. So I used the input function in Python. Then this slide shows what happens after those inputs are received by the system. So the system takes that location string and geocodes it into a latitude and longitude. That latitude and longitude are then supplied to the OpenMateo API for the live weather conditions in Bergen, Norway. The user prompt and the weather context are then combined and passed into Fashion Clip as a single string, and that returns a 512 dimensional vector query embedding, and these are the values printed out as a sanity check. Then we can use that vector to run cosine similarity search in our database per category. And here are the top 3 items per category formatted for the LLM. So here's where KPI 2 comes into play. I had judged 11 out of 15 retrieved candidates as being relevant for the weather and the prompt. So that's 73%. I think the tops and outerwear categories performed well. Bottoms is where it took a hit. You can see there's 2 sets of shorts being recommended here, which is not a good choice for a cold and rainy day. And one of the shoe candidates, these black lace-up boots, feel a little off for a professional setting. I think part of the issue there is that this is a poor description of the boots. These are actually more like combat boots, and I think if the word combat was in there, there's a chance they might not have appeared in this list of candidates. And this slide shows the actual system prompt I engineered for Llama. You can see it instructs the model to follow a strict 5-step reasoning process. First, you assess the weather, then you assess the occasion, and then you apply hard weather rules before selecting anything. So that includes things like, if the temperature is below 65 degrees Fahrenheit or cold, please don't select tank tops or open-toed shoes. And then from the remaining appropriate candidates, select the most stylish and coherent combination of clothing. And finally, output the selection in a very specific format, which allows us to parse the output and visualize the actual clothing images to the user. Getting this prompt right was one of the more iterative parts of the project, and I'll discuss that in the lessons learned. So here's what came back from that scenario. Llama selected a black t-shirt, gray pants, black leather ankle boots, and a black puffy jacket. You can see the actual photos here on the left and Llama's explanation of why it selected those on the right. It correctly walked through all 5 steps, so it said, hey, it's cold and rainy, it's a professional occasion, and it applied the hard weather rules correctly, so it eliminated any tank tops, shorts, open-toed shoes, and it made sure to include outerwear to provide warmth. It also correctly identifies that the black leather ankle boots add polish while being practical for the weather. So for KPI 2, I judged 100% of these items as being relevant individual items for the prompt, and it also correctly selected outerwear for this outfit. KPI 3, which is, do these items together make a coherent outfit and would I wear it? I mark this as a pass. I would genuinely wear this to a client presentation on a cold day. And did this scenario run end to end? Yes, so that's a pass on KPI 1. Now the worst case scenario. This was fancy date in Marrakesh. The prompt was, I'm going on a 3rd date with a guy I really like. We're going to dinner at a very nice and fancy restaurant, and we might walk around afterward. I want to feel dressed up and put together, but still like myself. And again, here's the code cell on the right using that input function. I won't go over all the internals as I did with the previous example, since the process is exactly the same, but here's where things started to go wrong. The candidate pool for this scenario shows 15 items across all categories, and look what came back. For tops, we have a gray t-shirt, a long sleeve blouse, a white tank top. We have olive green khaki shorts, grayish blue loose casual comfy shorts, and sweatpants. The one pieces I think were actually the best, so a jumpsuit, a maxi dress, a navy dress, but you'll see later that none of these were actually chosen for the final outfit. For outerwear, these are too heavy. I have outerwear that is lighter, but none of those were selected. And for shoes, I think sneaker and lace-up boots, again, like these don't make sense for either a fancy restaurant or super hot weather. So my KPI 2 evaluation is that only 5 out of 15 of these candidates are relevant for the user prompt and the weather conditions. I think the one pieces saved that number from being even lower, but like I said, none of them are selected for the outfit later on. None of the tops or the bottoms and a lot of the shoes were appropriate for the prompt. So here's what it finally chose. Llama selected this shirt and these bottoms. I described this as in my written report as reading like summer pajamas, and I would not wear this to a very nice restaurant under any circumstances. The interesting thing is Llama's reasoning. It correctly identified that it's hot and it shouldn't select heavy outerwear, but then it described the gray t-shirt and loose shorts as a cohesive and stylish combination for a fancy dinner, which they absolutely are not. The model convinced itself this was appropriate, I think, because the candidate pool wasn't giving it a lot to work with. I do think it's interesting that it opted not to use any of the one pieces, which is what I would have done in this situation. Because I would never wear this is a fail on KPI 3, and I would not choose any of these individual items for this context, so it's also a failure for KPI 2. This failure, I think, points to a real architectural limitation. So I had initially not included the weather context in that user prompt embedding phase, but that meant that a lot of the items that were returned were not taking weather into account. So I ended up putting it back in, and I think that works when the user prompt and the weather are kind of pointing in the same direction. So for example, the professional meeting in the cold weather, both the weather and the event context point to the same kind of clothing. So they both point to darker, covered, more structured clothing. But when the weather and the user prompt conflict with one another, I do think that one of them tends to dominate. So in the worst case scenario, I think the hot weather signal was so strong that it pulled the retrieval almost entirely toward casual summer clothing, and it drowned out all of the signal from fancy restaurant. So that leads me to my 3 lessons. First is that I'll actually start with my third one. LLMs are reasoning tools, not rule following tools. So for example, Llama would explicitly acknowledge a constraint early on and then violate it in the very next sentence. So that's what caused me to move that weather constraint upstream into the retrieval phase, so that the model never had an opportunity to override it. But then we see some of that push and pull that I was talking about earlier, where the weather and the user prompt signals might conflict with one another. The first lesson I learned was that pre-trained models inherit the biases of their training data. So Fashion Clip was trained on product catalog language, which is comprised of studio photography with structured descriptions. When I fed it conversational prompts like fancy third date, I was asking it to operate outside of its training distribution, and I do think that made the retrieval quality degrade accordingly, which makes me wonder if there's a way to cleanse the user prompt such that it's more compatible with these embedding models. The second lesson is that prompt engineering and model parameters really do make or break the system. When I was first building this, Blip2's descriptions were very hallucinated forum comments, and it just took me doing grid search and personal evaluation of the outputs to get that output to be what I needed, and that was absolutely no new code. So that's really important. The other thing is that my initial Llama system prompt did not have a step-by-step reasoning framework, and I think that poorly impacted the output. And once I gave it that step-by-step reasoning framework to think about what the weather is and think about what the occasion is, I do feel like that improved the output quality. So here's all my references. Thank you so much for your time, and I'd be happy to take any questions.